Okay.
Yeah, okay, sir.
Okay. So the one of the important point when we are trying to do, the k-means is, what is the best value to find out the k. We did in a k algorithm also, what is the best way to find out what is the suitable k, and then here also we need to find out what is the value of k. And that's the important stuff. Okay. So what we can do, how it does, the k-means cluster. Okay. When you have 1,000 points, okay, you have 100 points, okay. So when you say k equal to 4, it randomly assigns the 1,000 points or the 100 points to the 4 cluster. It never first time it never checked the distance. It assigns, okay, you go there, you go there, you go there. It assigns into the 4 group. Then it starts the calculation. The k-means starts the calculation and find out the best k sets. So this is what I told assign each point to the cluster of the nearest seed points. The initial is randomly, then then find out the distance and compute the seed points, the new centroid or probably mean of the cluster. Then I move the points near to the cluster. Then stop the movement. There is no new assignment. That means the membership of each cluster no longer changes. That time we are going to stop it. That's the mechanism of our algorithm of k-means. But I explained in a probably graphical manner, which I explained already here. But if you look at here, I have all the points. Probably I'll assign it to 3 or 4 clusters. Then finding out the mean of the clusters. Then the means keep on changing and the points keep on changing within the clusters. Then I'm finding your new mean, and finally there is no movement happening. So that's what we are doing it in this particular slide. So it's a very machine intensive algorithm. So it takes some time, if you have more data points and more number of, the features, it will take long time to calculate. Okay. So one of the point is, how to choose a k value. Okay. Okay. So like I said, even the previous class of KNN, the best way to choose is, we call as, the elbow pattern. Okay. Probably initially you can, take a cluster of, 1 to 10 or probably 1 to 20 and find out the error between the cluster means and each point in terms of the distance. Okay. And, try to plot this, the mean square error and the cluster in a scatter plot, and then it will give you indication what is the best k mean to select. I'll give you examples. So we did in a KNN method. We'll do the same thing the k means also. Okay, so that's a one
Yeah,
method. Okay, one method. Always that will be the best indication of the k value. Okay. So when k is 1, probably the error will be on the other side, higher side. Then if you increase the k, to 2, 3, 4, until some point, it will come as a bell curve or a small, curve which is going to minimize the error. And at certain point, it will come closest to 0. It never becomes 0, but it comes closest to 0. That point, we can stop that k value and take the k value for our clustering algorithm. Okay, so that's a method for choosing the k value. And here I'm talking about some of the data sets. We are trying to use the IRIS data set, which has which can be used for clustering. But I'm going to use some of the data sets for clustering. We can use ggplot. We can use the k-mean clustering comes in between inbuilt package within the R. So you don't need any kind of install the package. Only for plotting, whether you can use ggplot or cluster. There is something called cluster plot algorithm, which is trying to plot the clusters. Which is very easy way to group plot the points in a different groups.
yeah, okay.
So any doubts so far, Ajay?
No, sir.
Okay. So let's go into a small exercise or data set. and we can try to differentiate the clusters. So
Yeah.
So whatever I spoke to you is explained here, the cluster algorithm. I'm not going to run through this particular worksheet. I'll leave it to you. I'm going to run the other, sample which I had in the code. Okay, I'll
Yeah.
try to explain. For this, you can use this one to understand the k-means clustering and the various algorithm here. But I'm going to
Yeah.
use some of the data sets so that I can explain in much better way. Okay, so I have a data set called mall customer. Okay, this is a data set of customers who visited a particular mall, during a particular day, and I want to segregate the customer based on certain categories. Okay, so I don't know anything about that, but I collected some information about the customers. So
Okay.
if you look at that, the customer, so I have only, probably two data points I have. What is the annual income in terms of, just one minute, this is not the data set I'm talking about, but so this is a customer data set which I collected. Okay, this is a customer ID, whether the person is a male or female, and age, what is the annual income, what is the spending code, probably they have to calculate something on that. But we can calculate, or we can take any data sets. If you can go to any website which give you any kind of data set, we can get the data sets. So I'm trying to cluster this customer based on the values, mainly the income and the spending score. Okay. So what I did here, from the data set, I extracted only the column of 4 and 5. So column 4 and 5 is nothing but 1, 2, 3, 4 annual income and spending score, and I'm trying to do the clustering based on these two values, because the customer ID, male or female, is not important for me, but even if you can take it, it will give a different clusters. So I can explain, if you have the data set is different, the cluster also totally different. Okay, so I'll explain that one. Okay, so I'm going to take only the between the two columns. So I extract the data sets, keep it in the same data set. So probably I'll keep it as data set one. Okay. So the new data set has only two data points, which is annual income and spending score. Okay. So always the first point is I need to try to find out the error within the cluster. Correct. The error should be as minimum as possible. Correct.
Yeah. Okay.
Okay. So as usual, I'm setting the seed. When you're setting the seed, it will set the random point as same when we try to execute the same code multiple times. So so I can take the seed of anything. Probably even if you want, I can put 5, 6, 7, 8, something like that. Then I'm initiating a variable called WCCS. This is nothing but within cluster sum of squares. So sum of square is nothing but one of the error method which we are trying to calculate. Okay. So what it's trying to do is going in a loop. I'm taking initial, probably taking a 10 loop, or case equal to 10. Okay, this can be any value. So I'm trying to plot a graph within that for while loop, and I'm trying to calculate you know uh, yeah a value nothing but within square. Within square is one of the output which will return by k mean square. So first I'm trying to find out I'm running a k-mean square for the entire data set. This is nothing but when I say 1, the k-mean square is 1. And when it's 2, k-mean square is 2. So I'm trying to do an experiment of 10 k-mean square and trying to find out the sum of square method. So it's running in a for while loop. So this is nothing but what I'm trying to do. I'm trying to do an experiment. Okay. So I can do probably with the 1k equal to 1, I can execute. So when k is equal to 1, the within sum of square is this much. So when k is equal to 2, so this is 2 sum of squares. Okay, this is the first the group which is sum
So,
of.
Sita, the k-means is the inbuilt function.
Yeah, it's inbuilt function. When you install the R, it automatically comes. No need to install any library.
Yeah, okay.
Okay. So when k is equal to 3, it gives 3 clusters and the distance within this particular cluster.
Yeah, okay.
So
So for when the for loop will run, so it will give the set for the 10th 1 to 10, right?
correct. So when I do 1, the sum of square is 26,000. So the point will be somewhere here. Okay. When
Yeah.
when I try to do 2 clusters, that means the separation is much better when compared to the clusters equal to 1. So the sum of square will be less compared to the previous group. So if we look at it's 11 plus probably 6.5, it will be 1800. So points come here. And if you do the big
Yeah.
group, it will be further less. It's 7.8 plus 1.4, which is 9.2 plus 1.3, which is 10.5, which will come here. So like that, if I do 10 times, the sum of square within the cluster will keep on reducing it. Okay, so it comes keep on reducing it, and finally, I can get the sum of squares for all the 10 clusters. So that's what this for while loop does it. Okay, it just to try to find out the distance for all the clusters between 1 to 10. Sorry, I need to put a data set 1. Okay. Now what I'm going to do, I'm trying to plot a graph between the value I calculated, which is within the cluster sum of square, and the plot has various parameters. Like I'm going to give a title, which is Elbow method. In the X label, I'm trying to give the number of clusters, and Y label, I'm trying to give the WCCS, and I'm executing this particular plot. So it's executed. It's going to give the same thing. I'm expanding it. So for the cluster 1, the sum of square is on the higher side, and it keep on reducing when I increase my number of clusters. It keep on coming in. At certain point, after 6 is not reducing much. The filter is not reducing much. Okay, because this is the elbow method at the point cluster equal to 6. Okay, the sum of square is probably around 4,000 mark. After that, if you look at it, it's not reducing much. Probably it's coming up to this one, but this was the indication. This is the use the best cluster. So I can use as a cluster as 5 or 6. So this is a 0.5. Which I can take it, or even I can take it as a 6, whichever way. Then I can give the input. I can
So,
give,
Sita, so if we take like 8 or 10, then what will be the result? Like, will be
so
overskewed? Like,
it
overfitted?
it won't fit it because you are going to get more clusters. So if you are going to give 8, you are going to get the 8 clusters. So the
Oh,
main difference is the right time to stop it, because if you're having more clusters, the competition will be more. Probably your business doesn't want that kind of clusters, correct?
yeah.
Okay. So you cannot target all the clusters or something. So you need to find out, or you need to balance it out between the the number of clusters and the errors and computation powers.
Yeah, okay.
Okay. You can if you have 100 points, you can keep 100 clusters. Right? That will give best way to split the data. But that's the way you want to work it. No, okay? That's not the business need.
Yeah, okay, Sita.
Okay. So you are trying to find out what the best way to cluster. That's what you cannot get the 100% satisfaction, but somewhere you need to stop it. Okay, this is my best way to do the clustering. That's what it's trying to do. Okay. Now I got that what is my best point. It will be a 5 or 6. I'm taking as a 5 as elbow point. So I'm going to set the seed again to to run the new clustering with the with the proper centroid. And so if you look at the Y means, you can get that all the cluster means. So you can find out how the 100 points is divided into various clusters by running this one. So point 1 is in the third cluster, point 2 is the first cluster, like that it will segregate the points into various clusters. So that's what the cluster mechanism will do. So once I done, probably no, sorry, this is a data set. I need to use data set 1, okay, because I split it into that one. So it split the point into various data sets. I run the data sets. Now I want to plot, because the points are kind of a differentiated within the various clusters. But you want to visualize in a better way, right? How this point, even though the observation 1 is a third cluster, and the observation 2 is in the in the first cluster, like that. Okay, so I want to plot this particular the cluster segregation in a better way. So we can use a library called cluster. Let me put it there. So I'm loading as usual. There's a graph or point called the function called cluster plot. You take the data sets and you take the y mean value and plot the graph or segregate the points into various clusters. So that's what it's going to do. It's going to have a different colors. It will have the different shades. You can look at the various parameters. You want to look at the various parameter of the cluster plot. So this is a formula. You can look at that one, but I gave a lot of points which we needed for plotting it graph. So let me execute. And so look at the points. I have did the 5 clusters, and the points all fall into properly. I have 1, 2, 3 points. All the points, like the points, the observation 1, observation 28, observation 18, which are falling into a similar cluster, and observation 3, 33, 19, 17, which are falling into a different cluster. So like that, it will plot the graph so that you can easily understand which customers or which observation falling in different clusters by using graph. Yeah. So if I use all the data points instead of 2 and 3, if I use including age, also point, like then it will give a different meaning. So instead of 3 and 4, I'm going to give 3 and 5, because initially I took only that clustering between the annual income and the spending code. If I go to use, it will give a different points, but the underlying concept is totally the same. So once you cluster these customers or cluster this point, you can give back to the business saying, okay, these are the different type of clusters. Or you can do further algorithms, or business can take some action. Okay, what are the product I'm going to select? I want to target the annual income is above these number of people. So if they can send a target email or to these customers, and they can omit all these small customers on high-end product. And similarly, if you want to find out a small end product, you can target these customers rather than targeting these customers. So they know, once you do the clustering, then they can where to target, they can find out easily. So that's what clustering all about. Probably you can execute the another exercise which I showed to you. Which is going to work on the iris data sets. But you can take any data sets. You can take a couple of what you call couple of features, and from the feature you can try to cluster the points. Like here I took the features of the spending score and what you call the spending score and annual income, and I clustered based on these two features. But you can take any data set and try to clusters. You can take 1 or 2 or probably 5 or 6, and you can cluster the points.
Yeah, okay, Siddha.
Okay, so that's what our clustering all about. Any questions before we end up the class? Tomorrow we are going to talk about natural language processing, and which is explaining here. Okay. So I upload this script as well as the sample exercise which I mentioned here, into the the SharePoint or the Drive, Google Drive. You can go through the exercise. You can take any of the data sets and you can go through again.
Yeah. Okay.
So when you run the the k-means, the k-means written log of the parameters, just you can execute what is the within cluster error and everything you can find out. So if I say the k-means with total within so this will give the total error of all the points. This is one cluster, this is one cluster, this is one cluster, this is one cluster, this is one cluster. So in the ideal way, all the points here should be merged with the cluster centroid, correct? So it's not ideal. That's ideal way, but because the points are spread across within the cluster, like 400 is further away from the cluster mean, so it will calculate the error between these 2 points. Okay, so this is the error within this particular cluster called within. Within this particular cluster, what is the error? But if I give the total within, it will calculate the error for this particular cluster, calculate this error for this particular cluster, and sum up all the error. That's called total within.
Yeah. Okay, Siddha.
Okay. So like that, we can keep on doing it for all the we have various other parameters. You can go through. If you have the between the clusters, then it's nothing but what is the distance between this mean and this mean? What is the error? So this what gives a betweenness. So we want to minimize finally this and this. That's what we are trying to do. So when we are finding out the k value here, when we are running this particular plot, when we try to do the elbow method, for the particular k value of 5, this should be minimum. These 2 points. That's why the k value is coming as a perfectly fine. Okay, so you can explore all of the parameters. Kiran, it's the parameter list is given here. I'll upload all these. These are reference which I got it from the particular stuff. So you can explore all the points. Okay, so it's the easy way to do it. Only thing you need to understand the various, how the clustering happening. What is the algorithm it takes, how the points move between the various clusters, what is that within the errors, what is the total error, those things you need to understand. So once you understand how the clustering happens, the lines of code is very, very minimum, which is only 3 or 4 lines, and you can execute and find out the perfect cluster.
Yeah, Sita.
Okay. So any questions before we wind up the class for today?
No, Sita, I'm good.
You perfectly understood, correct?
Yeah.
Okay. Okay, Kiran, I'll stop the recording. I'll upload this material into, the drive, and you
Yeah.
can look at for your reference sometime later today or tomorrow.
Yeah, okay, Sita.
Okay. Thank you, man.
Okay.
Good day and good night.
Thank you. You too, Sita. Thank you.